People always dreamed about an artificial companion for playing games. Already in the late 18th century, a very popular automaton was developed which was able to play chess with a human. Later it turned out that the chess-playing Turk was a fake, as a hidden person inside the automaton controlled the game. Today people are used to use artificial opponents for playing games. Either these opponents are pure virtual, as in computer games, or not interactive like chess computers. The next step is a smart physical opponent which is able to play a game on a real game board in the real world. The challenge is to combine the different areas such as game theory, software engineering and robotics. Pylos is a popular two-player strategic board game. You can buy it in any toy store. The rules of Pylos are very simple. At the beginning the board is empty and all spheres are in the reserve. The game goes on until one player places a sphere on top of the pyramid or a player runs out of spheres in the reserve. Once a square of spheres is formed on the board, the player has two more options. Either he puts a sphere from his reserve on the square, or moves one of his spheres already on the board up to the square in order to save spheres. A player who makes a square of its own color may take back one or two spheres to his reserve. Pylos has a high game tree complexity, because the same situation may reoccur later in the game. We solve the game by using state space complexity, which is less complex than the game tree. In order to be able to play a game like Pylos, a robot has to master several challenges. It has to recognize the situation on the game board, has to decide what valid move to do next, and has to physically manipulate the spheres on the board. The Pylos playing robot is built up by off-the-shelf components. The robot recognizes the situation on the game board by detecting the spheres with circle fitting and color matching. The estimation is cross-checked with the possible moves from the successor situation. The manipulation of the spheres was taught in manually. We use a customized reserve to make the grasping of the spheres easier for the robot. As a result, we now have a robot which is able to play Pylos autonomously. It recognizes when a human player did a move and reacts with its own move by physically moving spheres. The robot is able to play optimally, which makes it hard for humans to beat the robot. In the future, we want to generalize the hardware and software for various board games like chess or Nine-Man's Morris. The ultimate goal would be a general platform which is able to recognize various board games and offers to play the game with someone.
Checkmate.